Bonjour and yeehaw! Here we go, chapter 5, lesson number 5. This is the review lesson. Just like all the other review lessons, this does not include every slide and every example. It is just me going over all the key points from the other lessons. It is what we have learned in this chapter. If you're wanting anything explained in a little more detail, or if you want to see more examples, look back to these individual lessons. So, what was this chapter all about? Well, we started looking at factorials. What is the point in factorials? What are factorials? Well, factorials is when you have a number and you multiply it by all the numbers before it all the way down to 1. And factorials can be used to work out the number of different combinations, and really it's a way of making long calculations quick and simple. For example, how many ways could 5 people be seated on a bench? Well, the first person would have a choice of 5 empty seats. The next person would have a choice of 4 empty seats. The next person would have a choice of 3. After that, they would have a choice of 2. And the last person would only have 1 choice. So to work that out, you do 5 times 4 times 3 times 2 times 1, which will give you 120 ways. A quick way of writing that is to write down the number 5, but put an exclamation mark after it. The exclamation mark is read as 5 factorial. And it means you're multiplying that number by all the numbers before it all the way down to 1. On the calculator, there is a button that looks like this. It is the factorial button. And using factorials, numbers get quite big very quickly. For example, 12 factorial, if you put that into the calculator, bump, 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 you get 479,001,600. A special note is that 0 factorial equals 1. Really, factorials is to do with the combinations, so how many different ways can you arrange 0 objects? Well, you can only arrange them one way. There is one way to show nothing. We were evaluating, for example, 6 factorial, and we saw that 6 factorial is just 6 multiplied by all the numbers before it, and it gives us 720. Negative 4 factorial, if the negative is in brackets, you have to do this differently, but if the negative is not in brackets, just work out 4 factorial, and it'll be negative, whatever that answer is. Remember, 0 factorial is 1. Woo! If you have to write down 7 factorial in terms of 6 factorial, well, 7 factorial means 7 times 6 times 5 all the way down to 1. But here we've got 6 times all the numbers before that, so we can write that as 6 factorial. And that is us writing 7 factorial in terms of 6 factorial. Evaluate negative 5 factorial. The negative 5 is in brackets. You can't do that. Error. Factorials show you how many ways you can arrange a certain number of objects. You cannot have less than 0 objects, so that will not work. Other examples, we have to simplify 6 factorial over 4 factorial. Well, when we're doing that, 6 factorial over 4 factorial, you can see that we have a 4 factorial, 4 times 3 times 2 times 1 on the top and the bottom, so that will cancel out, leaving us just with the 6 times 5, which will give us 30. It's the same if the numbers get bigger. 23 factorial over 20 factorial. 23 factorial, we don't have to write that out as 23 times 22 times 21, all the way down to 1. What we can do is we can look at the bottom and think, right, well, we've got a 20 factorial here, so if we can express 23 factorial in terms of 20 factorial, that will cancel the 20 factorials. So 23 factorial is 23 times 22 times 21 times 20 times the numbers before that. In other words, 20 factorial. You can see that you have it at the top and the bottom, so you will cancel, leaving you with 23 times 22 times 21, which will give you that answer. If you have another example, here we've got n factorial over n minus 2 factorial. Remember, n factorial just means n multiplied by the number before that, so whatever n is, take away 1, multiplied by the number before that, which will be whatever n was, take away 2, and so on. But again, look for the same factorial at the top and the bottom. Down here, we've got n minus 2 factorial. So we can express n factorial in terms of n minus 2 factorial. That way we will have it at the top and the bottom, so they will cancel, leaving us with n times n minus 1. Multiply the brackets and you get an answer. After we looked at factorials, we then went on to look at binomial coefficients. To introduce that, I was looking at different people on a bench. Again, we're looking at combinations. So a bench seats 2 people at a time and there's 4 people wanting to sit down. How many ways can 2 people be selected to sit on the bench? So here we're wanting to select 2 people from a group of 4. And in maths, when you select R objects from a list of n, you can express that as what is known as a binomial coefficient. And it is written in brackets and it's read as n choose R, or you can have NCR. This is a button on your calculator. The way it is worked out is by using the formula n factorial, so n would be how many objects you have, and r factorial, r is how many you want to choose. And at the bottom you've also got n minus r factorial. Some examples with that. Using the example from the last page, if we have the group of 4 and we want to choose 2, well, we write it down as 4 choose 2. That, if you plug these values into the formula, you will get 4 factorial over 2 factorial, 4 minus 2 factorial. Just work that out. 4 take away 2 is obviously 2. Again, you want to try and express 4 factorial in terms of 2 factorial, which we're doing, meaning we can cancel a 2 factorial from the top and the bottom. Always look for different ways to simplify your factorials. Try and get the same one at the top and the bottom. Here are other properties which we looked at in some of the examples. We looked at calculating 6 choose 3. Now 6 choose 3, you could use a calculator for that, but if it was a non-calculator paper, if you had to do it without, you would use this formula just up here. Hello, look at this formula. And that would give you n factorial would be 6 factorial, r factorial would be 3 factorial, and n minus r factorial would be 6 take away 3 factorial. Again, you want to simplify that. 6 take away 3 is 3. Express 6 factorial in terms of 3 factorial, and they will cancel, leaving you with 20. How many ways can 3 dogs be chosen from a group of 5 dogs? Woof, woof, woof. Well, here we've got 5 and we want to choose 3, so we will have 5 factorial over 3 factorial, 5 take away 3 factorial. Again, we're just using this formula. Express 5 factorial in terms of choose the larger one, cancel these numbers. You get 3 factorial, so express 5 factorial in terms of 3 factorial, and they will cancel, leaving you with 5 times 4 over 2 factorial. Remember, 2 factorial just means 2 times 1. Cancel them, and you will end up with 10 for your answer. We went on to look at some of the harder questions. Oh no! But we managed them no problem. If we had to choose, for example, if we had to solve n choose 2, but we know that's equal to 28, well, we can sub these values into this formula and we can solve for n. So n choose 2 would be n factorial over 2 factorial, n minus 2 factorial, as is written here. From there, well, n factorial means n times the number before that, n take away 1, times the number before that, n take away 2, times the number before that, all the way down to 1. But don't write that out, you'd be there forever. Write it as n minus 2 factorial. That way you have an n minus 2 factorial at the top and the bottom. Do I? Yes, and that means you can cancel. So I'll leave you with n times n take away 1 over 2 factorial. 2 factorial means 2 times the numbers before that down to 1. In other words, just 2 times 1. Multiply both sides by 2. Subtract 56 from both sides. Solve it by factorising. Ta-da! And then you get 2 possible answers with n is 8 or n is negative 7. But remember, n is how many objects you have. You're going to have more than 0 objects. So here, n would be 8. If you have negative 7 objects, that makes no sense. So it's going to be your positive value. We were using the other properties here. This property, n choose r equals n choose n minus r, to find the value of n if n choose n minus 2 equals 55. So what we had to do first of all was rewrite this using this property. We were really just going back the way. Because we've got an n at the top, that just stays as n. So here, n at the top will just stay as n. R you can rewrite as n minus r. So what we can do with n minus 2 is we know the value of r is 2. So that's the same as n choose 2 equals 55. And from there, it's very similar to that last example. Express n factorial as n times n take away 1 times n take away 2 times the numbers before that. Cancel out an n take away 2. Write 2 factorial as 2 times 1, which is 2. Multiply the brackets. Multiply both sides by 2. Subtract 110. Factorise, solve, and think about the question. Remember, you cannot have less than 0 objects. It's going to be a positive number, so n here would be 11. For this one, again, we're using this other property. For this other property, what we've got is n choose n r take away 1 plus n choose r equals n plus 1 choose r. So find the value of n if n choose 1 plus n choose 2 equals 28. Well, what we can see here is, again, you've got n in the top and n on the top again. So really, because we've got n at the top and n at the top, that's just going to stay as, well, it's not. It's going to go to n plus 1. Use this property here. You can see that whatever n is, you're adding on 1. So we're going to write that down as n plus 1. The property here, we've got an r take away 1 and r. So in other words, a number and the number before it. And at the bottom here, we'll go to r. So here we've got a 2 and a 1. So we've got 2 in the number before it. So r would be 2, which we've got. From there, that's just very similar to the last example that we did. So that'll be n plus 1 factorial over 2 factorial, n plus 1 take away the 2 factorial. And again, you can simplify that and work your way through. Look back to the lesson explaining this if you want more. Lesson 3, we looked at the binomial theorem, and the binomial theorem is used to expand the likes of x plus y to the power of n. What we saw was if we do expand x plus y to the power of different numbers, to the power of 0 would just be 1, anything to the power of 0 is 1. To the power of 1 would give us x plus y, square it, this is what you get, cube it, this is what you get, and so on. Notice the powers of x, if you take one of the lines, the powers of x descend from whatever the number is for the index, all the way down to 0. So we've got x to the power of 4, 3, 2, 1, and x to the power of 0, which we wouldn't write, that become 1. Powers of y would ascend, so we'd have y to the power of 0, which again, you wouldn't have to write, that's 1, then y to the power of 1, y to the power of 2, to the power of 3, to the power of 4. And also the sum of the powers is always whatever n is. So here it's 4, but you notice if you add the powers, you get 4. If you add these powers, 3 and y to the power of 1, you get 4. 2 add 2 is 4, x to the power of 1, y to the power of 3, again you're getting 4. What we're interested though in is the coefficients. Do they follow a pattern? Well, if you think about the coefficient here, we've just got a 1. We've got 1x, 1y, 1 and 1. 1x squared, 2xy, 1y squared. Write down the coefficients. What we'll notice is to get each row, you're always starting with a 1. Then what you're doing is to get the number here, you would add these 2 diagonally above it. So 1 add 3 is 4, 3 add 3 is 6, 3 add 1 is 4, and then we're finishing with a 1. This follows that pattern for the coefficients, which means then the next line we could work that out, just adding the numbers above and so on, starting and finishing with a 1. But if you expand x plus y to the power of 6, the coefficients will follow that pattern. So we'll have 1x to the power of 6, then 6x to the power of 5 times y to the power of 1, and so on. We can use that knowledge of Pascal's triangle along with our knowledge of binomial coefficients. These values here in Pascal's triangle, you can write them as the coefficients, which we were looking at in the lesson before this one, so in lesson 2. 1 you can express as 0 choose 0. 1 again you can express as 1 choose 1. 1 you can express as 1 choose 1. Again, 2 can be expressed as 2 choose 1. So row 0, you've got a row at the top, which is row 0, and the entry starting on the left-hand side with 0. Then here for row 1, well, the one at the top is the row, and then it's entry 0, and then entry 1. Here with row 2, you've got the second row, so all the numbers at the top are 2, and then you've got entry 0, 1, and 2. Going down here with the 7th row, you'd have 1, and then 7, and then 21. So you're starting off with 7th row. So at the top, if you write that out as binomial coefficients, you would have 7, 0. And then this would be 7 choose 1, 7 choose 2, all the way along to 7 choose 7. So, binomial theorem, if you want to expand x plus y to the power of n, you're going to write down your binomial coefficient, which will be the values in Pascal's triangle. So whatever n is, you'd have n choose 0, n choose 1, n choose 2, all the way up to n choose n. X, you start off with this power, whatever n is, and you're subtracting 1 each time, all the way down to x to the power of 0. And with the y, start with y to the power of 0, and then you're going along y to the power of 1 to the power of 2, all the way up to y to the power of n. Quick way of writing that is this here just means the sum of. So you're taking x and you've got that to the power of n minus r. You've got y and you do that to the power of r. It is the sum of, it is what you get when you add each of the terms. So you're starting off with r is 0 and you're going up to n, whatever n is. Each term in this sequence will be n choose r, x to the power of n minus r, y to the power of r. And when r is low, you want to use Pascal's triangle. For example, here, if you want to expand x plus y to the power of 5, well, you would have 5 choose 0, 5 choose 1, 5 choose 2, all the way up to 5 choose 5 as the binomial coefficients. X is whatever is first in the brackets. So here we've got an x, so we're keeping that as x to the power of, and we go to the power of 5, then 4, then 3, then 2, then 1, then 0. Y is whatever is second in the brackets. The bit that's second here is positive y, so that'll be y to the power of 0, then y to the power of 1, then 2, then 3, then 4, then 5. And you can use the binomial coefficients, replace them with the entries in Pascal's triangle. So start off writing that down, 1, 1, 1, then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, y 5, 5, 10, 10, 5, 1. And the 5 choose 0 will be 1. 5 choose 1 will be 5, 5 choose 2 will be 10, 5 choose 3 will be 10, 5 choose 4 is 5, and 5 choose 5 will be 1. So you can replace the binomial coefficients with the entries in Pascal's triangle, and then you can simplify that if possible. For example, x to the power of 0, you wouldn't need to write. Y to the power of 0, you don't need to write. We were doing quite a few examples with that. Just be careful if you have a negative. If you've got a negative, you need to include it. So here, because it's to the power of 3, we know when we expand it, we'd have 3 choose 0, 3 1, 3 2, all the way up to 3 choose 3. This here, the 1 is the value of x, so we'll have 1 to the power of, starting with 3, and we've got 1 to the power of 3, then 2, then 1, then 0. The negative 4x, remember, keep the negative with it, that will be to the power of, well, you're starting with r is going to be a 0. So that'll be negative 4x to the power of 0, then to the power of 1, 2, and 3. And you can then simplify that, replace these values with what they are in Pascal's triangle, and then simplify the rest of it, giving you your answer. Just be careful when you move on to some of the harder questions. So there are x's here, and you've got x's here, and we've also got this negative. So be very, very careful. With this one here, 3x is going to be the value of x, if you think about each of the terms in just your general term. So we're going to have 3x to the power of 4, because we've got the 4 here. So we'll have that 3x to the power of 4, then 3, then 2, then 1, then 0. The negative 2 over x squared, we'll have that going up the way, so that'll be from the power of 0, then 1, then 2, then 3, then 4, and we've also got these binomial coefficients as well. Work your way through that, simplify it, and this is the answer that you will get. If you want to see me explain it, look back to the lesson. Use binomial theorem to find 0.4 to the power of 4. So one way of doing that is to express 0.7 as something plus something, or in this case, something minus something. An easy number to go for is 1, so express 0.7 as 1 take away 0.3. That way, you would have 1 to the power of, and then because we've got a 4 here, you'll have 1 to the power of 4, then 3, then 2, then 1, then 0, and they're all dead easy to work out. They would all just stay as 1. You've then got negative 0.3 to the power of, and then that's 0, then 1, then 2, then 3, then 4. And again, you've got these binomial coefficients, and you can start working that out. The last lesson, what we had to do was find the coefficients. So if we had, for example, x plus y to the power of 7, well, you could expand that using your binomial expansion, binomial theorem, but it'll take you quite a bit of time. There is a quick way of doing that using the general term. What you do is you would express this general term, because this is to the power of 7, you would have 7 choose r. You would then have x to the power of n minus r. X is whatever is first in the brackets. Here it's still an x, so we've got x to the power of 7 minus r. And y is whatever is second, so here still y, so it'll be y to the power of r. We want to simplify the general term as far as possible. Well, in that case we can't, we just leave it. What we then do is we look for the coefficient we want. Because we're wanting the coefficient of x cubed y to the power of 4, take just the x or the y, whichever one you want. So you can have x cubed, and you know that the x to the power of 7 minus r will eventually become x cubed. So set them equal. Just going off to the side to do that. Because the base is the same, the indices will be the same, so you'll have 7 minus r equals 3. Solve that to find r. Once you know r, you can then sub that back in to your general term. You've already subbed in the 7, now sub in the 4. So you'll have 7 choose 4, x to the power of 7 minus 4, y to the power of 4. 7 choose 4, use Pascal's triangle or the NCR button. On the calculator, that gives you 35. This will give you x to the 3. This is still y to the 4. You're asked for the coefficient of x cubed y to the 4, and you can clearly see the coefficient is 35. We did quite a few examples like this. With this one here, we want the coefficient of x to the power of 5 in this expansion. X take away 3 over x to the power of 7. Because you know it's a 7, you can replace the n with 7. So you've got 7 choose r. X is whatever's first, still x. So we'd have x to the power of 7 take away r. Y is whatever is second, negative 3 over x. That'll be to the power of r. But we need to simplify that. Gather your x's together, and to do that you would move this x up to the top line. You don't have to, I just prefer doing that. Try it without doing that if you want. You'd have negative 3x to the power of negative 1. Because you've got the number times the x term and it's all to the power of r, you can split that up. So you'd have negative 3 to the power of r, and then x to the negative 1 to the power of r. Remember, when you've got something to the power of, you just multiply the indices together. So it'll be x to the power of negative 1r, or x to the negative r. You've still got this negative 3 to the power of r, but you've split up these x terms. You can now gather them together because the x isn't being multiplied by a number. So x to the power of 7 take away r times x to the power of negative r, same base, just add the indices. So 7 take away r, add negative r, is 7 take away r, 7 take away 2r. From there, because you've simplified that, you know that you're wanting the coefficient of x to the power of 5. So this here, x to the power of 7 take away 2r, will eventually become x to the power of 5. So go off to the side, set them equal. The base is the same, set the indices equal, solve that to find r, and once you know r, sub it back in over here, so you'd have 7 choose 1 in this example. X to the power of 7 take away 2 times 1, and then negative 3 to the power of 1. Once you do that, you can then use Pascal's triangle to find the value of 7 choose 1, and then all you're wanting to do is to evaluate that, so you get the coefficient. So the coefficient here would be negative 21. Find the coefficient of x to the power of 4 in the expansion 1 plus 2x squared, all to the power of 3. Again, this is very, very similar. You want to use the general term. Write down the general term, replace n with what you know it is. It's the power of 3, so that'll be 3. X is whatever is first, so it'll be 1 to the power of 3 take away r. Y is whatever is second, in this case it's 2x squared, so it'll be 2x squared to the power of r. After that, again, because you've got the number times the x term, split that up, so it becomes 2 to the power of r, and then times x to the power of x squared to the power of r. Remember, when you've got something to the power of, multiply them together, so it'll be x to the power of 2r. After that, well, you've only got that x term, so you're going to set that equal to what you're wanting. You're wanting the x to the power of 4. So that there will become x to the power of 4. Solve that to find the value of r, and once you know the value of r, you can sub that back in over here. You can then work that out. It gives you 12x to the power of 4, so you can easily read off what the coefficient will be. Just be careful. Sometimes what you will get is it may ask you to state and simplify the general term, and it will also ask you to find the term independent of x. If it wants the term independent of x, it means find the term without an x. In other words, you'll have a number times x to the power of 0, because x to the power of 0 will just be 1, and then x will disappear. The general term is n choose r, x to the n minus r, y to the power of r. Here, you know n is 6, so you can sub that in. Sub in these values as well. X is whatever's first. We've got a 2x, so it'll be 2x to the power of 6 take away r. Whatever is second is the y, so we've got negative 5 over x squared. That will be to the power of r. That is the general term, but we want to simplify that. To simplify it, it means to gather your x's together and any numbers as well, just put them together. So here, if you gather the x's going through the same method, move that up to the top line, split this up, so you've got negative 5 to the power of r and x to the negative 2 to the power of r. This is what you'll end up getting, but you can then put these terms together. It's the same base, you're multiplying, add the indices, and that's what you get. That's the only x term. We know that it is independent of x, so x will be to the power of 0, meaning it will disappear and that will become 1. So set them equal, solve to find r, and then you can sub that back in. Doing that, you will end up with something x to the power of 0, which will just give you a number, meaning that that is basically your answer. That is it for this chapter. You have been taught all 4 lessons. Try the questions in the booklet then. You're on pages 1 through to 10. Best of luck. Anything you're unsure of though, remember to look back at these individual lessons. Have fun. Bye.